All right, guys, so now let's look at numbers 2, 3, 4, and 5. So we're still on the same page. We've applied that strategy of, okay, I knew A and B were out, process of elimination on number 1, and I was able to narrow it down to C and D, which were answers that said the same things but about 2 different cars. So I had just had to figure out which one was true. So now we're going to look at number 2. Number 2 says when you coast down a hill on a bicycle, you move faster and faster. Then when you keep coasting on a level surface, you eventually stop moving. What causes you to stop? Now, these answer choices are very wordy, and we know that's true about our science tests. So remember, part of taking a science test is taking a reading test, and we have to think logically while really understanding what the text is saying. So it's okay to reread these answer choices more than once. The first time you read them, sometimes it's like brain overload, and then the second time, now I can actually think about what I've read. So if we look at these choices, F says no force is acting upon the bike on the level surface. I'm going to stop right there because I know that forces are always acting upon everything at all times, even if I can't see that force in action. So I'm going to eliminate F without even finishing reading it because it doesn't make sense. So F, sorry, you're gone. Then I get to G. G says after you reach the bottom of the hill, you run out of energy, so you stop moving. Well, remember on this problem, we're coasting down the hill. And coasting means I'm not actually doing any work. I'm literally gliding down. I'm not pedaling at all. So I'm not the thing providing the energy or the force to move this bike. So G is out. Then I get to H and I. So again, like number 1, now I've narrowed it down to my 2 final options. H says friction between the tires and the ground is an unbalanced force that changes your motion. So H is saying friction is the reason why, once I start to level out, I slow down. I is saying that gravity affects you when you move downhill, but there is no gravity when you... Hold on, is there ever no gravity? Not on Earth. I is out. I don't even have to finish reading it, which means the only answer here that makes sense is going to be H. Okay. So again, here are our answers for number 1 and number 2. Let's look at number 3, top of the same page. Katie uses all of her force to roll a bowling ball away from her body. So try to picture that as you're reading it, rolling a bowling ball away. Always ask yourself when you're taking a force of motion test, if the thing that they're describing is a push or a pull, it might give you insight to the answer. Then Katie repeats the same procedure with a soccer ball. How does the movement of the 2 balls contrast? So we're trying to figure out what is different about what I'm going to have to do to move both of these. So before I even look at my answer choices, I'm thinking, what do I already know? I know I'm trying to move a bowling ball and a soccer ball. I know that bowling balls are really heavy, soccer balls are very light. So I'm already thinking, well, I know I'm going to have to apply, if I want them to go the same distance, a lot more force to the bowling ball to get it to go as far as the soccer ball. So now that we've thought about what do we know, let's look at our choices. Number 3A, the soccer ball moves a greater distance because more force is acting on it. B, the soccer ball moves a greater distance because it has less mass. A and B are both about the soccer ball moving a greater distance. C and D are about the bowling ball. C is stating that the bowling ball moves a greater distance because it has more mass. D, that it moves a shorter distance because less force is acting upon it. Well, I know based from this problem that the same amount of force is being applied to each ball. So I can eliminate D and I can eliminate A. The answer to this question is not going to be about the amount of force being applied to it. It's going to be about mass because that is the thing that makes these 2 things different. It's their mass. The bowling ball has a much greater mass. So I'm eliminating, again, that was D, and I'm eliminating A. So now I'm down to B or C, which are both about mass. I just have to figure out which one's true. B says the soccer ball moves a greater distance because it has less mass. C, the bowling ball moves a greater distance because it has more mass. Things don't move a greater distance because they have more mass. Mass is something, increasing mass slows the motion of an object down. So the only one in this case that's going to make sense is going to be B. Because the soccer ball has less mass, it's going to move a greater distance. Okay, so last one on that front page, number 4. A spring scale measures force. And again, there's a really good picture of a spring scale on your test, just to remind you what it looks like. What is the force that causes the reading on the spring scale shown in the illustration? So what we really have to think of here is when we put something on a spring scale to measure its force, what force is acting upon it that helps give us the reading on the scale? The way spring scales work generally is they're pulling something down, and then it's reading the force based on that pull. So I just have to think, well, what is the thing that the force that we all know, not the Star Wars one, that pulls things down to the ground? It's going to be gravity, right? And there it is, choice H. I don't even have to consider the other options, because the one thing I know for sure in this force and motion unit is that gravity is a force that pulls things down to the ground.